Hello, everyone, and welcome to the next episode of the Belinda Carr Show. Today, we're going to be talking about thermally modified wood. I made a video on this product a couple of months ago, I don't remember now, but it is fascinating. I don't know how I came across it. I think it was an Instagram ad.
Benjamin Ueda actually posted something about that, and then you said, "Oh, that is awesome," and you went and got in touch with them, and they got back with you and sent you some samples.
You're right. That's how I found out about it. They sent large samples, big planks, to Benjamin Ueda, who's supposed to be making some wild contraption out of it.
Probably shipping container exterior facade.
I don't know about that, but it just looked so gorgeous. So I contacted the company. They sent some of these samples over, and I got the CEO of the company on our podcast. Now, he didn't invent this product. It was invented in Europe in the 90s, but he's bringing it to the States, and it's obviously gaining a lot of popularity.
So, did you ever have anyone in architecture school like try to do this?
Burn wood?
Yeah.
No.
Okay. I recall, I'm not sure if it was an undergrad or graduate school, where there was someone that had a project, and it's probably undergrad. It was probably my friend Luke, who was crazy. He just loved experimenting.
The skateboard guy?
No, not skateboard guy. This was the guy who would go down to the shop and just weld something randomly because he figured out how to use the welder.
Sounds like your grandfather.
And he'd bring it upstairs and it'd be like, "Guys, check this out." And it was this ugly lump. And he's like, "This is so cool." And then he went back down and started doing it again.
So he tried burning wood and seeing
So
what
he
it
was
would
very
do?
experimental, yeah. So I think he was building some furniture or something, and so he just took a torch over it to like burn it all. And I think,
It's like a creme brulee.
yeah, I think we also saw someone do that at Dallas Makerspace.
Torching wood.
Yeah, and I guess is that the same thing?
It's not exactly the same thing. So the Japanese version of this is just to take wood and torch the surface. Well, you put it in this like triangular thing and heat it up, and you mainly torch the surface. What this is that the whole piece of wood is put in an oven, and the whole piece of wood is heated up. And then Arbor Wood takes it a step further, where after the wood is stabilized and cut to the right shape and cleaned up, then they take a torch and torch the top surface. So it's a two-step process.
Do they torch all of their pieces? Because it looks like that other piece right there is just treated and not torched.
You're right. This is just cooked, but I think this and then the other black piece that we have, that has a charred top surface.
Okay.
So it is similar to creme brulee because you cook the custard in the oven, and then after that you put sugar on top and then torch it with a burner.
So it's the creme brulee of building materials.
Yeah, that's right. So let's learn a little bit more about how this thermally modified wood is made. Today we're with John Heyesen, co-founder and CEO of Arbor Wood in Minnesota. Thanks for joining us, John.
Thank you, Belinda. Happy to be here.
So I first came across Arbor Wood, I think on Instagram, and I was just fascinated with it because how gorgeous it looked. And I reached out to y'all a couple of months ago. Y'all sent me these samples for a YouTube video that I made. So tell us a little bit more about Arbor Wood, how you came across this product.
Sure. So Arbor Wood is a thermally modified wood product that we produce here in Minnesota. Thermal modification is all about improving outdoor stability and durability of wood through a natural process. We became aware of this thermal modification process through a relationship we have with the University of Minnesota. Here in Minnesota, the university has a natural resources research institute that's intended to be good stewards and build economy around a lot of the natural resources we have, not only here in Minnesota, but throughout a lot of the United States. And so they're really sort of experts and kind of a guidepost for good stewardship of really our country's natural resources. And some of those folks have been involved with thermal modification kind of at the ground level. And so this process was developed in Europe in the mid 90s. And it's really through an existing relationship we had with the university that they made us aware of thermal modification. And so we've been fairly early adopters here in North America and have really seen the market kind of grow and expand right in front of our eyes. So
So Arborwood your company was started in 2019, but you do have a different company that you have been growing and building for a couple of years, right?
That's correct. Yeah. So we run a separate company called Intextural, which is a distributor of architectural building materials that all have some story and sustainability. And so a lot of the materials that we've historically distributed through Intextural are manufactured by other folks. We work with people in the Pacific Northwest. We work with manufacturers along the West Coast who all produce really unique and interesting and sustainably produced products. And along the way, we made this connection with the University of Minnesota and thermal wood modification and basically built a brand, which we call Arbor Wood, that had been housed within Intextural's product portfolio. And just as we've seen the industry sort of blossom, we're now getting big enough where Arbor Wood is its own company. And so we're growing, the market's growing. It's an exciting time.
So of all the products that you do offer at your other company, what is it about thermally modified wood that just stood out from everything else? Was it its uniqueness, its appearance? What do you think it was?
Yeah, I think there are maybe three things that attract people to thermally modified wood, and maybe made it attractive to us as a manufacturer and as a distributor. First and foremost is aesthetics. It's a beautiful product. I mean, wood has just been part of how humans have built things for thousands of years. Wood never really goes in or out of style. The story of sustainability then has become an important topic for people. People are paying closer attention to how products are made, how they impact the buildings and the places that we live and occupy. And then I think when we talk about supply chain, when we talk about versatility, thermal modification allows us to explore a lot of different wood species. And so there is a flexibility, a kind of a malleability where this technology and this process works across a whole range of wood species. So now we can look at different species that either grow in abundance, that don't have maybe a good value in traditional exterior application. We can take even a hyper local focus and look at species of wood that grow sort of indigenous in different parts of the country and apply the process to give new life and utility to those woods.
So it's kind of that versatility. So let's dive into that, exactly how thermally modified wood is made. It's a 3-stage kiln process, right? It has no chemicals in it, and it's just purely heat and steam, right?
That's correct. That's correct. And the essence of the thermal modification process is about degrading the hemicellulose to a very specific level. And so you mentioned that 3-stage process, and essentially there is an initial stage that reduces the moisture content of the wood almost to zero. And in so doing, we are eliminating a lot of the sugars, the minerals, the naturally occurring food sources for things like mold and rot and fungal decay. All of that gets sort of cooked out of the wood in that first phase. The second phase then spikes the temperature very high, typically around 200 degrees Celsius. These are nitrogen-rich, oxygen-starved environments to prevent the wood from combusting. And it's during that phase that modification really happens. So it's that breaking of the hydroxyl groups, and that then renders the wood what we call hydrophobic, which means it actually repels water more so than wood would naturally do. And so there you have dimensional stability, and you sort of eliminate the wood's ability to absorb new moisture. And then that third and final phase is really about cooling the wood. We reintroduce some steam, which helps to condition and bring moisture content back up to around 5 or 6%. And then that's how the wood goes into finished profile, finished molders, and we turn it into siding, decking, dimensional lumber.
That's fascinating. And y'all have control over the entire process. So y'all can achieve different colors and different textures and all, depending on how much you'll heat the wood up.
That's right. Yeah. So for lack of a better term, the sugars are almost caramelized during that high heat process. And what happens, just kind of as a really lovely sort of unintended outcome of the process, is you have these rich tones that the wood sort of that are imparted on the wood. And these colors are through colors. They're effectively baked all the way through the full thickness of the board. So when we're talking about siding, when we're talking about decking, when we're talking using arbor wood in some sort of a construction environment, when you're cutting and ripping and chopping boards down, you're not having to color match those cut edges, because that color goes all the way
All the
through.
way
And
through.
that's right.
And it doesn't look superficial. Like you can tell, even the side profile, the color is consistent. It's not just like right on the surface that, like you said, if the top surface gets chipped, you're not going to see any other different color underneath.
That's right. And there are no pigments, no dyes, no chemicals used to achieve that color. And so you don't have maybe some of the plasticky looks that you would get in composite products. You just have beautiful natural wood.
Do y'all apply any sort of finish to get the darker colors?
We do. So thermally modified wood proves to be a really good canvas, generally speaking, for paints and stains and finishes, because again, it's dimensionally very stable. A lot of paints, a lot of stains, they bond well to the material, and they're less prone to peeling or flaking off. We've also found, for whatever reason, that it's a good platform for charring and brushing and exploring some really interesting finishes. And so we at Arbor Wood have our take on traditional Japanese yakasugi or shusugi bond, as some people are familiar with, and it can actually char the surface of the board. And because of the stability of the fundamental stability of the wood itself, that char really remains intact. It's less prone to flaking off and chipping off, and makes for a really, really beautiful board.
So I looked into yakasugi when I was making the video on like thermally modified wood. And I think traditionally they only charred the surface, but you all have a two-stage process. You all actually, the wood is actually thermally modified. And then after that process, you all char the surface.
That's right. That's right. So throughout history, that charring process has been about wood preservation. And in our case, we have this improved amount of wood preservation by virtue of thermal modification. So that charring, that yakasugi process, I suppose, adds some additional stability and durability to the wood, but it's really about aesthetic. And yeah, at the end of the day, you have wood that has sort of two different approaches to natural protection. And it's a 25, 30 plus year solution. And in many cases can be very, very low maintenance or even maintenance free.
Yeah. So where are these manufactured?
Yeah, so all of our manufacturing happens here. All of the final manufacturing is here in Minnesota. We have a modification kiln here in Minnesota. We also work with a secondary kiln partner in the greater part of the Midwest here that helps us keep up with capacity. All of the finishing then is done here. We're located in Duluth, Minnesota. We're also in the process of building a new facility, so we will have a fairly state-of-the-art thermal modification production facility right here, basically in Duluth, that should be online around the end of the year. But everything is done domestically with woods that are all harvested kind of throughout the greater Midwest and the southeast part of the country, and it's entirely a domestic product.
So did the manufacturers that you approached, did they have to modify their existing machines to do this, or were they already making thermally modified wood?
Yeah, the people that we are working with to modify the wood have expertise in modification, and we've kind of developed the recipe in partnership with the University of Minnesota. So it's kind of been this three-pronged approach to kind of honing into our specification and honing into our product. The profiles themselves have just been a sort of an evolution based on R&D and experience and demand and all those things. Yeah, and so it's very much been an evolutionary process, and it's been a team process.
So tell us a little bit more about the facility you're building. How is it going to be powered? Because I'm sure a lot of people are concerned about the amount of energy it takes to heat this wood up. And do you all capture the heat that's released during the process?
Yeah, we do. Great question. So at the heart of our new system is our thermal modification autoclave. What's going to be different about our new modification plant is that we are bringing what's called a closed system autoclave. And so where we talk about heat and steam, we are now incorporating pressure as a third element to the modification process. So our new modification kiln will be pressurized. And that means
would lower your energy consumption.
That's right. So we can actually modify the wood at lower temperatures, which of course requires less energy to heat up the kiln to the appropriate temperature. It's also putting less stress on the board. So we're achieving the same level of modification. That pressure is kind of driving that heat energy deeper into the hemicellulose and the sort of the mass of the wood. And so we don't need as much heat. We don't need as much time under heat. And so we have a product that actually has greater durability, greater stability, more consistency, greater predictability throughout the process, and requires less energy to get there. But we also, at the end of the day, are still modifying thousands of board feet of material at hundreds of degrees Celsius. And so we do have some heat reclamation infrastructure within our facility that helps to heat the facility without any sort of external heat sources. And even a lot of the material, part of the waste stream from our process, such as the water used to condition, even some of the dust collection, there are some studies that we're currently working on to find ways to apply a value add, whether it's through biofuel or even organic fertilizers. So there are some really interesting ways that we can capture everything involved in making arbor wood and do something good with it.
So you just talked about waste collection. So when wood goes through the thermal modification process, it does get warped a little bit. So you all mill this down to get this perfectly straight wood.
Yes, that's correct. Yep. So milling happens after modification, and the wood is stressed. There's checking and some end cracking in the rough timbers that we have modified. And so finish milling happens after that. And all of the sawdust, everything that is removed from the rough timber, we're going to capture that. And there are some good use cases emerging. Like I said, biofuel being maybe the most compelling, where we can repurpose a lot of that waste material.
So right now, what's the main demand for this? Is it on residential homes as exterior cladding? Is it on schools or larger buildings, commercial buildings?
I think thermally modified wood and a lot of the natural wood modification processes, thermal modification is not the only sort of natural modification technology that's emerging. I think all of those are becoming less niche here in the United States. And so we're seeing interest, we're seeing increased demand across a lot of different vertical sectors. We're certainly seeing it in the residential space. Homeowners are becoming more and more aware of thermally modified wood, and we've seen sort of significant growth in that space. Even commercial and institutional projects where long-term durability and low maintenance and natural materials are all part of sort of the mission. We're seeing growth there. I mean, these materials contribute to LEED. And so if there are large projects where LEED accreditation is a priority, thermally modified wood helps support that. And then there's a whole emerging space within OEMs, manufacturers, everybody from guitar luthiers to stand-up paddleboard manufacturers, who are starting to explore using thermally modified wood for all of the reasons that we've talked about: the stability of it, the beauty of it. We're seeing it as an eco alternative to rosewood or ebony or mahogany. And so we're really interested. We have some studies kind of underway to even explore more utilitarian applications like railroad ties, utility poles, things of that nature. So, we're still just kind of scratching the surface on what's possible with modified wood and what other processes can be applied to it to give it even greater stability and greater utility. So it'll be interesting to see what the next 10 years.
That's interesting. You said guitars, and that's exploiting a feature of thermally modified wood. Like, heat and moisture is not going to cause drastic changes to the shape of this wood. So it's going to constantly keep the guitar in tune all the time.
That's exactly right. And guitar necks are probably the most common emerging use case for modified wood in a musical instrument application, for that exact reason. If you are a touring musician, you're bringing a guitar in and out of the car, in and out of the club, in and out of church, wherever you're playing. You're going to have fluctuations in relative humidity and in temperature that can oftentimes cause an instrument to go out of tune, and modified wood helps address that.
So what are the different profiles that you all have?
Well, we are producing siding and decking would be kind of at the foundation of our product line. And so right now with siding, we have a fairly traditional nominal 1x6 tongue and groove profile. We've been working to sort of expand how we approach this profile and are actually looking at some end matching as well. So we have the standard tongue and groove joint, and then we also have an end matched option on those boards. And then of course, decking, another great use case for modified wood. So we have decking profiles. And again, we can run really any wood species that we're modifying into any of these profiles. I would say there are seldom is a species of wood that works in one case, but not in the other. So we're able to produce kind of everything from everything. And then
the edge profile was really interesting because you mentioned that it's going to speed up installation.
Right. Yeah. So with both cladding and decking, it's really important to have airspace between, behind both of those surfaces. And so if we're talking about cladding, for example, our recommendation often is to install siding over some sort of wood furring. What becomes important when you're doing that, or what becomes necessary when you're doing that, is you have to have one row start the next sort of run along that row over a furring, which means if you're 3.5 feet to the next furring strip and you grab a 4-foot board, you're going to have to chop off and sort of lose some of that material that you've already paid for. Well, with end matching, it becomes less important to land over furring or over a joist. And so you get an increased yield, which also increases the speed to install it. And it's just overall a better system. It has better strength and torsional rigidity kind of along every axis.
So I noticed that you all actually have the grain of the wood matching in that piece that you just showed as well. Was that just purely coincidental?
Yeah, that is purely coincidental, because as we've been testing some of these new types of joints, we actually just cut them from a single board. Piece. Yeah.
Because y'all don't have control over that. This is just pure natural wood. You're going to get whatever grain you get. So y'all can, you've mentioned this a couple of times now, you can use pine wood and convert it into, like, typically pine was used indoors. It's not used outdoors. You use something like hardwoods outdoors. But if pine goes through this process that you've described, so this thermal modification, it can be turned into this like caramelized, beautiful wood that can be used as outdoor siding.
That's absolutely right. And softwoods in general are perhaps the most commonly used species of wood, or general classification of woods used around the globe as it comes to thermal modification. Everything from pine to spruce to balsam fir, very, very popular for that reason, because you can take wood species that typically don't have good outdoor utility. They're oftentimes less expensive to source than exotic woods or hardwoods, and you can run them through this process and build some really beautiful things with them.
So what about things like beetle infested wood? Are you all able to use things like that as well?
Not really. And an important part of the process is that it's very much a garbage in, garbage out process. Yes. And so all the wood that we do source, we do have a fairly tight spec and a fairly tight tolerance. We even
because it can't have large knots, right? Because all that will fall through during the firing and the heating up.
That's right. Yeah, oftentimes large knots and large through knots have a tendency to shrink during modification, and they fall out, and then you're left with the big void in the board. And so, yeah, so for us, we're sourcing fairly select grades of rough timber, and that's both for performance and as a result, it also makes for we think, a more beautiful and aesthetically pleasing finished product too.
So since you are in the wood industry, I can't not ask you about how you've dealt with the crazy lumber prices over the last 2 years. It's probably affected y'all quite a bit.
Yeah, what's interesting is that a lot of the wood species, a lot of the woods that have been more volatile are woods that have been more commonly used. So we've, cedar, for example, has been extremely volatile. I think the woods that we're using for arbor wood and that people are using for thermal modification, they just haven't had as much market proliferation yet. And as a result, the pricing has not been quite so volatile. So we modify white ash, for example, and white ash does not have quite the economy around it as a cedar. And so it has surprisingly been more stable. It's always been a little bit more expensive. It's always been a little bit more difficult to source. And so that hasn't really changed. And we've been able to hold pricing fairly consistently throughout all of 2021, 2022. We've had a couple of very, very modest price increases, but for the most part, we pride ourselves on being fairly price stable. And again, the technology is as much a part of the story as the wood species we're using. And so as a certain type of wood becomes less readily available, ash, for example, is something we're paying attention to with the emerald ash borer here in North America, where the surplus over time is just getting smaller and smaller. There are other domestic hardwoods out there, red oak being one of them, that visually looks very, very similar to white ash. It modifies very similar. The recipe is almost identical. So we have this ability to insert different types of wood as other species become either difficult to source, expensive to source, whatever it is.
So do y'all have to constantly keep up with these changing recipes depending on the type of wood available? But also you talked about in your new facility, you're going to have this pressurized system, which is going to completely change your recipe. So all these experiments, are they being conducted by y'all or by the university?
Yeah, they're being conducted by us. So we're working very closely with the manufacturer of our new kiln based in Denmark. And we're developing these recipes as we speak. So we're sending large truckloads of wood to this new style of kiln, and we're sort of running different charges and doing some product testing on it. We're doing what's called EMC testing, which is equilibrium moisture content testing. We're doing some stress testing, some accelerated weathering testing, with the idea being that come mid to late October, November, when our new facility is online, we're ready to hit the ground running. We've kind of already developed these recipes. And actually, Europe uses a lot of pine. They use a lot of pine wood sort of around a lot of Western Europe, where thermal modification is very, very popular. So a lot of the recipes have been fairly plug and play. Some of the hardwoods like ash and oak, for example, are more what we're focusing on right now. But you are correct that the recipe is a little bit different for species of wood based on moisture content and a number of other factors.
So what are the plans do you have for the rest of the year? I'm sure building the facility is taking up a lot of your time, but how do you see Arbor Wood growing in the next couple of years?
Well, we're pretty passionate about what we're doing, both just through our pedigree and our history within textural, and now with Arbor Wood as well. We really care about helping bring materials to the marketplace that are gentle on the planet, that are beautiful, that are long lasting. And so we want to continue to put that narrative kind of out there. I think as it pertains to Arbor Wood, there still lacks standardization and here in the United States. And so there are a number of different ways that people are producing modified wood. And we would like to help prop up the industry by working towards standardization, which just hasn't happened. So we're sort of leading the charge as an industry to work with the American Wood Protection Association and a lot of the accreditation agencies here in the US to define a standard that can then be incorporated into US building codes. We're also looking at additional treatments and additional processes that can be added to modified wood to help with fire abatement, can help with termite resistance. And so there's a lot of excitement.
Wood that can be used inside the house too, not just as exterior cladding?
That's correct. Inside the house, outside the house, even potentially ground contact. So there are some natural processes, natural chemicals, natural compounds that can be impregnated into thermally modified wood. We're finding borates, things of that nature that can help with termite resistance and just increasing durability.
Well, that's exciting. Well, thank you so much for sharing all that information. Like I said, it's just beautiful. And I think the word caramelized is just the perfect way to describe thermally modified wood. It just looks like caramelized sugar. It's just gorgeous. So thank you for sending me all these samples and explaining how the process works, and hope to come visit your new facility later on this year.
Absolutely. We'd love to have you.
Yeah. Well, thanks again, John.
Thank you, Belinda.
So my favorite part about Arbor Wood and this thermally modified wood process is that it basically turns softwood into hardwood. Not structurally necessarily, and I may be wrong on that, but the look of hardwood from softwood. And that's something that, like, as a novice furniture builder, I've always built with softwoods because they're a lot cheaper, and it would be so nice to build with like a maple or a really nice hardwood, but it's just out of the price range of normal people.
You're right. Yeah, it does look a little bit like higher end than what you'd expect softwood to look like. So that is awesome. But also it performs a little bit like hardwood. Like this is this can be used for exterior purposes, which you traditionally can't use softwood for unless it's chemically treated.
You can use cedar on exterior.
But things like pine, you can't.
Okay, unless it's treated, right?
Yes, unless it's chemically treated. But this just because all the sugars are cooked out, it can be used outdoors. The one thing, obviously, is that once the wood is cooked, it does warp and shrink. So this looks like beautiful solid wood pieces, but this is milled.
Right. Yeah, he did say that in the podcast.
The edges are cleaned up, the top surface is sanded down, the grooves are cut. It's all milled from really pretty like warped boards after the cooking process.
Yeah. So there is a little bit of waste in that sense, but at the same time, it's supposed to be pretty stable now after it's gone through that process. So whenever you have it as your deck outside, maybe it won't warp and bow over time as much as an untreated wood.
Yeah, and then the other downside is, like we just mentioned, the waste from cutting all this product, but also the heat used to cook this material. So they're building a new facility, like you mentioned, and they're hoping to open it in November or December of this year. And their idea is to create a closed loop system. So the 30% waste after milling it is going to be burnt, and the heat from burning that waste will be used to cook the next batch of this product.
They're not just going to buy carbon credits?
Touche. They probably still get carbon credits and be able to use the energy to cook it. I should tell him about that. If he probably already knows, but that's basically biomass, and biomass is considered to be clean energy.
That's what I thought whenever he first mentioned that they take the waste and they're going to use it. And I was thinking, oh, biomass.
Yeah, and get carbon credits out of that and be able to create a new product.
Yeah, at least, I mean, it sounds like a pretty sustainable product. Like you said, the issue is the heat. But he also mentioned whenever it goes through that initial process, they have to like starve it of oxygen and introduce a lot of nitrogen or something.
Steam. Steam is introduced at the end. I don't know about nitrogen.
Okay, I remember he said nitrogen in there somewhere. So that made me wonder: is that like, does that take away from it being as environmentally friendly because they have to source all that nitrogen?
I don't know about that. I don't think that's an issue. The other concern is that this silvers over time because it's wood. It doesn't stay this way when it's outdoor decking or when it's siding. And architects and interior designers are so concerned about the appearance. Like they want it to look like this 5 years from now. So unfortunately, Arbor Wood has to sometimes treat the top surface with stains just so it satisfies the interior designers.
But the thing is, with stains, it's still going to wear over time. Like, you're going to have to restain it at a certain point. You're going to have knockoff come in and restain it.
Well, that they do masonry, but yeah, that's funny. But yeah, I wish they would just accept it for what it is. If it's silvers, it's silvers. It's aging.
And there are some architects out there that consider that. Like, I think, for example, the D. Young Museum in San Francisco, it's made of copper panels. Like, the way it looks now is completely different to what it will look like whenever it patinas.
It's still copper right now and brown, but it's supposed to turn green eventually in the future, like the Statue of Liberty.
Yeah, and then you have, was that copper?
Statue of Liberty?
Is made of copper?
Yeah. It wasn't green originally.
It's not like made of marble or stone?
No, it's metal.
Huh. I've never touched it. I've just seen it from afar.
You're an American. Well, I'm an American too.
I'm definitely cutting this part out because it makes me look like a bad American.
Yeah, it was copper originally.
I think about, there was a building that I saw in the Netherlands. I believe it's Norman Foster. But it was an example of the architect making the conscious choice to patina the copper panels before it was installed. So the building was green immediately.
That's cheating.
Yeah, that is cheating.
Yeah, I don't appreciate that kind of. Just let the building age. Let it do its thing.
That seems like a very modernist technique. I'm in control of nature.
I'm going to force it. I'm going to force this appearance right now. So similar with this, if you're going to stain this beautiful product, you're forcing it to be something that it's not.
Like I said, I like it because it looks like a hardwood, but it still is a softwood. You're just changing the appearance.
Well, right now, when hardwoods seem to be the same price as softwood or even cheaper sometimes, it may not be a viable alternative, but eventually when softwoods come down in price, then this could be a good option.
Definitely. And it's more renewable than a hardwood is, and it's more eco-friendly in that sense.
That's true. That's very true. So if you want to learn more about this product, check out arborwoodcompany.com. They have a website and an Instagram page, and check out my video on this product too. Join us next week for another episode on building science, products, and technology.